For this elevator project, I went to 46th Street in Indian School at the Safeway complex at the public elevator. I went up one story, then back down one story, and I recorded the video shown below. After each initial acceleration, the elevator began moving at a constant velocity, which is shown with my constant weight displayed in the video. Then, when it would accelerate in the opposite direction, the scale would shift weights. All of my weights are taken from the videos, then I converted them. There is a short acceleration, but when it does happen, that's the shift in the scale. This is because of Newton's third law, which causes an opposite reaction on the scale, causing the shift in the weight.
This is Robbie. Now that we have our video evidence, we're going to do the calculations on paper. So, first of all, we're going to start out by taking the video where I weigh 171 pounds, or and then we're going to need to convert that into kilograms. So, then we take the 171 divided by 2.2, because that's the conversion. Let me take our calculator. So 77.727 kilograms. And so now that we have that, I took some previous notes. I took some previous notes, and now that we have this, we're going to draw a free body diagram. Then we also have to use the equation n plus negative w equals ma, and then we'll be able to solve it. So I'm going to write down the equation f equals ma, just like that. And then I'm also going to assume that the acceleration is negative 9.8 meters per second. And since we're only dealing with the y direction, the free body diagram is going to have no horizontal lines. Alright, so the free body diagram of the elevator. Here's the elevator. It's kind of a box, but you get the point. So there's the natural force that pushes it down, or no, the natural weight that pushes it down. There's the natural force that pushes it up. And so this is the free body diagram, and since the acceleration is moving either up or down, that's why it moves. So right now we're analyzing the video, and as you can see, it went from 171 pounds up to 181 pounds, and then it went down to 159 pounds, and then it went down slightly before to 168 pounds. So I wrote that down, and it starts 10 seconds into the video, and then the whole ride itself is 14 seconds long. And then now we're going to do conversions on 181, 159, and 168. 181 divided by 2.2 equals 159 divided by 2.2 equals, and then we're going to do 168 divided by 2.2 equals. Alright, so I skipped a little bit, but I took the pounds right here, as you can see the pounds, then converted it into kilograms right here, and then I converted that into newtons, and then I took the original weight and then converted it as well. And then I also drew this diagram, and so it starts, the whole thing is going up, so the whole ride is going up. So I started with the initial weight in kilograms and then in newtons. Then I put in the effects of the forces, and then
I ended it. So in order to find the acceleration, you have to use the equation n plus negative w equals ma, as we also took notes on it. So, there's the notes. So then I took the conversions of the newtons, and I took the least amount in newtons that was given, so the 707, plus the natural, or my body weight, which was the 760. And then I did it all over the mass, which was 77.56 kilograms. And then I just solved it, and I got a negative 0.69 meters second squared. And then on the opposite side, I did second squared. And then on the opposite side, I did the exact same thing, but I took the highest number that I received, which was 805, and then I divided that out, and I got the acceleration at 0.5737 meters squared. So now that I finished the going up part and the equation, I then did the exact same thing for going down. I wrote out the measurements again, the original, because I didn't change my weight. Then how I shifted, and then original, then shifted, then original. So now I wrote out the equation again, and then I will solve it. And there's the conversions for the weights as well. So I just finished the calculations, and there's all my work. And I found out that the maximum acceleration was 1.261 meters squared, that the minimum acceleration was negative 0.57 meters squared, and that is on going down. So we found out both all four of the accelerations going up and down on the elevator.